It's another math day here with teacher Jenny. Join me for another topic. This time we're talking about evaluating logarithmic expressions. So let's try to consider on the properties of logarithm. So we have here if b is greater than 0 and b is not equal to 1, then now take note our b is the base. So if we have positive base and except for 1, then we have this following properties as log of 1 to the base of b, that will be equal to 0. So to simply say it, once you have their um, base b and you have 1 or any base there, and if you have there 1, automatic that will be equal to 0. Okay, next is we have 2 log of b to the base of b, that will be equal to 1. So if you have here the same number on the base, and so with the number here, automatic that will be equal to 1. Another one is log of b to the power of x. So your number here must be in exponential form. And if this number or the base of this number here is the same with the base on that subscript of log, then that will be automatically equal to the exponent on this particular base. So which is x. And then this is the same as if you have here an exponential form containing an exponent with a log expression. If their bases are the same, so the base here and also the base as the subscript of the log there, if they are the same, automatic whatever is the number in here will be your answer. And please take note that you cannot take logs of negative number because again, you don't have a base which is a negative. So expected your answer there, if you're raising that particular base to an exponent, any exponent, you won't have a negative answer to that. So let's now try out our examples. So first, we have evaluate our 8 to the base or log 8 to the base of 2. How do we evaluate that logarithmic expression? First off, we are going to check if the properties can be applied. But if you try to look at that one, there is none on that property that is going to be applied here. So we will be using our exponential form. So how do we convert this into exponential form? Always take note that a log is an exponent. So our exponent here, we can just place an x there for that unknown value. And when we say evaluating logarithmic expression, what we are looking for is the answer of that log expression. So remember, a log is an exponent. Always the answer to the logarithm expression will be your exponent. So we can write here an x. Now, converting that one into exponential form, we have that one as 2 to the power of x equal to 8. And then we can now solve for our x by simply converting our 8 here into the same base as what is on the left side. So we have 2 to the power of x. We convert our 8 into base of 2. This is now 2 to the power of 3 because again 2 times 2 times 2 is 8. And then since our bases are the same, we are going to follow the property of your exponential form that if their bases are the same, automatic our exponent are also the same or equal. So that means that when you say log of 8 to the base of 2, that will be equal to 3. So let's go to another example. Now here again, we cannot apply the property presented a while ago, so we just go for converting this one into exponential form. So again, a log is an exponent, so we can try to put a variable there for our exponent, and then we can write this one into exponential form with 2 as the base. X is an exponent because again, a log is an exponent, and that will be equal to 1 over 16. Now we are going to solve this x here by simply converting 1 over 16 into base 2. So this is now 2 to the power of x. That will be equal to, take note this 1 over 16, so this is in fractional form. If we wanted to make it into whole number form, we can just flip this or get the reciprocal. This is 16. And since this is raised to the power of 1, once we try to get the reciprocal automatic, we'll be changing our sign on that exponent, which is 1. So that will be negative 1. And then converting 16 to the base of 2, so we have 2 to the power of x, that will be equal to 16 will be 2 to the power of 4. That is your 16. But then again, we have negative 1 here. So we try to raise that up into negative 1. So we have 2 to the power of x. Simplifying this part, we have power to power rule, meaning to say we are multiplying inner exponent and outer exponent. So we have 2 to the power of negative 4. And again, they have now the same basis. So we have to equate the exponent. X is equal to negative 4. And then going back to the logarithmic expression there, log of 1 over 16 to the base of 2. This is equal to x which is equal to negative 4. So that will be our answer. So let's go to this one. We are to evaluate log of 1 to the base of 4. Now, if you can see this is 1 here, automatic this will be equal to 0. That is coming from the properties under logarithmic expression. So again, once you have here 1 on this part here of your logarithmic expression, automatic that will be equal to 0 regardless of whatever is your base in there. As long as it satisfies that the base is greater than 0 but not equal to 1. So let's go for the next one. We have evaluate log of 3 to the base of 3. Notice this number and the base are the same. So automatic this will be equal to 1. Because again, if you try to go for converting this one into exponential form, you will have that 1 as 3 to the power of x, which is equal to 3. Notice we have 1 as exponent here. So that is why you have there log of 3 to the base of 3, that's equal to 1. And again, once you have there this number and this number are the same, automatic that is equal to 1. Next one here, this is part of the property. If you have the base here, which is similar to the base on this particular part, automatic this will be equal to the exponent of this base here. So whatever is the exponent there, that will be our answer on the exponent part. So let's go for the next one. So here, this is also part of our property in which you have a number raised to the logarithmic expression, and the base of that logarithmic expression is the same with that base. So automatic this is equal to this number. Now here we are going to evaluate log of 2. We cannot see any base at all, but that is what we call as the common logarithm. This is understood that we have the base 10. So how do we find the answer for that one? You will be needing a calculator for that. You will be inputting there log and then 2. Or some of the calculators, you can have it as 2 and then pressing on the log button. So here is what you are going to view on the calculator. So in getting your log of 2, all you have to do is to locate your logarithm, the log. Once you located that log there, you are going to press on your number 2. So again, this is log, and then you are to press also this one. So this will be giving you this particular value. If your teacher is telling you to round it off to hundreds place, then your answer will be like this, or you can have it as 0.3. Next one, we have evaluate ln2. In evaluating this kind of format or this kind of problem, all you have to do is to, again, you'll be needing your calculator. So how to input that one? If this is your calculator, you can locate your ln here, and then you can press on the number 2. So just like this one. And then you will be seeing this particular value. So if your teacher again is trying to get a value which is rounded off to the nearest hundreds, then you can have this answer. So let's go for the change of base formula. Now some of the problems on logarithmic expression, evaluating logarithmic expression, you will be using the change of base formula. So what is change of base formula? So from the word change and base, we have now the picture that we are changing our base. So how to change our base? So let a, b, and x be positive real numbers, except that your a there must not be equal to 1 and b must not be equal to 1. And x is greater than 0. Then your log of x to the base of a, that will be equal to log of x to the base of b over log of a to the base of b. So this is how we change our base. Or to say it, when you have there your log expression, we have log of x to the base of a. All you have to do is to just cut it like this, and then just insert your log. And there you go, log of x over log of a. But then again, if you are having to change it into particular base, then you will be inserting here a base. But more likely when you have a problem there, most of the problem are going to be changed into a base of 10. Okay? So let me rewrite this one. The a here, it looks like my exponent. So it should be in line with this one. So again, you can just apply a slice on that one, and then so that you may not memorize that, you can apply your slice and then put your base in here. But then again, if you have the base 10, then you don't need to write that. So where the value of base b can either be base 10 or base e, which is our natural logarithm. So let's try this out. Evaluate log of 3 to the base of 2. So again, we have log of 3 to the base of 2. So as I'm saying, when you apply your change of base, you just slice it up and then insert log here. So that will be now log of 3 to the base, log of 3 over log of 2. So how do we get the value of this? You can just simply get the value of this by simply getting your log of 3. So you'll be inputting in your calculator the log of 3. This is equal to 0.477121254. And then your log of 2, that will be equal to 0.3010299995, and so on. Now, you can actually go for that one right away in your calculator. There are calculators that has a function like this. You can actually make use of that one. You can just input the number 3 here and the number 2 in there if you have that calculator. But if you don't have, then you have to go through with this one, the change of base. And then you will be inputting that on the calculator, the log of 3 divided by log of 2. So log of 3 divided by log of 2, that will be equal to 1.584962501. So if your teacher is asking you to round it off to the hundreds place, then you can have it as 1.58. So there you go. So I hope you're learning something from me today. And once again, this is your teacher, Jenny, saying, please don't forget to like, share, and subscribe for more videos. Thank you.